If you
Harish, you
just
have to.
if you switch the screen that you share into the one that that is a full screen mode, and then you're good. Oliver, can you help Harish to share the screen?
Yeah. Well, he should be able to.
This is perfect. Yes.
Right, all good.
This is like still the speaker mode, but I think we can work with it. You just need to share the other screen, or you can switch the. If you click display settings at the top, I think there you can just change the view from this to the other one. Yeah. So
There we go. Yep.
Thank you.
Thank you. Yes, so I'll be talking about Stiesdal approach to industrial alkaline electrolysis, who we are and what do we do. So Stiesdal is a company which is located in Denmark. As you see in the map over here, you see Denmark right above Germany. It's a small country. And if you zoom in Denmark, then you would see the Denmark's different locations and the 4 different spheres done in orange spheres that you can see that's the location where the Stiesdal offices or labs or manufacturing plants are located. It's a company which has more than 150 employees. Company has 3 subsidiaries, and the size of the sphere basically tells you the number of people those are located. So if you see in the center somewhere where we have the most number of people sitting, and that's a given location somewhere. So it's more of center, but it's called south of Denmark, which is Give. And that's where we have mostly hydrogen-related activities, all the R&D's lab, our assembly cases, manufacturing, testing areas, and everything. So if you look at the Stiesdal group management, then we have around 120 plus years of experience in technology development, in financing energy transitions. What we see here, we see 3 main Stiesdal management, and then we have a chairman of the board who has economic background. And the first 3 persons are basically having more of engineering background, and then going all the way up to top managements throughout their journey. Who we see here is the guy, Henrik Stiesdal, who is basically founder of the company, and the company coined on his name, Stiesdal. He's also the chief technology officer, and he has recently been awarded with the Queen Elizabeth Prize for Engineering of 2024. Overall, these all 3 are engineers, and that's why we do is more about the technologies. So Stiesdal is basically a climate solution company, a company that has been coined just to fight the climate change. And we have 3 main subsidiaries. One is hydrogen, where we develop alkaline electrolyzers and totally focus on industrialization of these electrolyzers. Then the second subsidiaries is SkyClean, where we have a pyrolysis plant, where what it does is more of the CO2 capturing. And third is offshore, where we develop more of floating foundations for offshore wind turbines. And all 3 subsidiaries are located in Denmark only. Today, we will only be talking about hydrogen subsidiaries of Stiesdal. What we use is basically classical alkaline electrolyzers technique. As we all know that it's a technology which is flooded with the electrolyte. That means that it limits the dynamics operation of this technology, and that's one of the disadvantages. And second is more of that having a lower efficiency compared to other technologies, whether it's a PEM electrolysis or solid oxide, but it is catching up. But what is good about alkaline electrolysis? That it's a well-established and proven technologies. Technologies is around a century old, and even there are multiple electrolyzers from 70s, 60s. Some of them are still operational. And then there was a kind of drought period where there was nothing happening, and now it's back to alkaline electrolysis. And most important, it's a very cost-effective, and that's why it can easily be scalable. And It's cost effective mainly because of using the low cost materials. So we do not use PGM materials, and that's why it's become pretty easy to implement those. What Stiesdal does to counter these disadvantages, generally we're countering the lower efficiency by compensating, by moderating, running it at a moderate or even low current density, and then making a technology around it so we can compensate these lower efficiency challenges. Second, that we have a flooded stacks, so we have a dynamic problem, and that can be tackled or enabled by operating the system at much higher pressure, and then we get a pressurized outcomes. And since the technology is well established and proven, so we get a multiple features to play around that gives that we could play around with the dynamics, to diaphragms, to cooling systems, and the gas separations, and that's how we could make this technology much more ready to industrialize. And since I'm using the word industrialization, and that's what we believe, that industrialization is the key to reduce the cost of electrolyzer. And here I'm giving example of two different scenarios. The case one where Ford Model T car, as you can see in the screen, in 1909 or 1923, the both cars were exactly the same in terms of specifications. What we see is small changes in the cosmetic, but the product itself was exactly the same. So what happened is that we see the cost of each unit and the unit that being produced in amount. And if you see that in 1909, the cost was somewhat sitting around $3,500, and that dropped to below $1,000 after nearly 8 million units being produced. So it's all about industrialization. More the amount you produce, lower the cost you could make. In the second case, if we look at the solar PV cost trajectory, then we see in 1976, the cost per watt was $81 when around 2 megawatt unit kind of installed. And when the time passed by, more unit being installed, and then the cost become 81 to 8, dropped to 4. And if we see now, in 2010 to 19, the slope was completely different. And I think that's the time when more of China, India's involvement happened, and we start installing more and more solar PV system. And then the cost dropped to even 26 cents per watt. And if you see now we are sitting around thousands of gigawatt capacity that being installed, and the cost dropped to even 10 to 15 cents per watt. Indeed, we would like to do the installation, but how it should not be as complicated as you see in the picture, where we have electrolyzer, that the juicy part is somewhat kind of hidden behind this balance of plant that we see over here. So what we do at Stiesdal is we try to make it very simple. We have 4 different blocks or boxes, where the one part having electrolyzer, and then all the balance of plant, which is these parts are somewhat not adding too much to the cost. So if you look at the cost, we see this plant, the cost was electrolyzer plus 200% on top of it because of the balance of plant. But that cost is dropped to 50% at Stiesdal production. So now you have seen the Stiesdal electrolyzer, how it looked like. We have basically pressure vessels. We have all our stacks is sitting inside the pressure vessels. And then we have a power supply and all the auxiliary system around it. So what we do is that instead of Stiesdal involving in the production of each and every component, we basically rely on the people those can do these things better than us. Those are in the industries for 30 years, 50 years. So pressure vessels of Stiesdal is basically manufactured by wind turbine power suppliers. Stacks done by plate heat exchanger manufacturing. Power supplies done by wind turbine controllers. And same for the auxiliary system, which involves all the separators, cooling fluids, and everything. Those are done by some mass production industries. So what we do more of what we are good at. We do designing, we do R&D around the structures so we can increase efficiencies, and we know how to assemble them in a nice way so we could make it industrially viable. This is what Stiesdal 3.1 megawatt hydrogen electrolyzer look like, where we have a stack module having a 2-stack unit into it. And this is the unit that goes inside a pressure vessels. Stiesdal uses very simple stainless steel electrodes. Therefore, we do not have any electrode coatings. we have very simple, basically inspection service replacement process by having a stack that is sitting on a lever that basically pulled out, push in, and that's make it very easy to do any sort of inspections. What we see here is the 2 units. Those are being installed, and that happened in 2023 at one of our customers' locations, where we are also actively participating to acquire more data and do more learning on running these 3 megawatt units. You see 2 units being seated over there. They are very easy, simple place and plug in system. And most important is that these units allow us to do the dynamic operations. And that's very important when you are relying on renewable energies, that you basically need to find a right electricity spot for the price, because you do not want to run the system all day with the capacity factor of 100%. You want to run the system where the cost makes sense to run it. And therefore, it becomes very important that these electrolyzers are operated at various load, and then they can do multiple on and off whenever it's needed. The unit comes itself basically in 2 separate trucks, very easy to deliver, very easy to install. As you see in the picture over here, there is one pressurized electrolyzer sitting on one truck, and similar, there would be another truck which will be carrying all the auxiliaries and the power supply units. Here we have currently 4 units, 3 megawatt each, operational in Denmark. We see here in the Glensager biomethanization plant, a plant where Stiesdal has provided 3 units of electrolyzers. Those are 3 megawatt each, and they are basically providing hydrogen, and that hydrogen being used in these methanization plants here. What we see here is how the operational data of the units look like on all 3 units. Since these numbers are updated only in October 2024, so obviously now we have a much more of operational hours, and that's where Stiesdal is also gaining its own experience. So this is our another project where we have a 4th unit running at another location called Mole, and that's also done in June 2024, and we already are setting. So that means that so far we are having 4 units. Those are being operationals and running fine. We are gaining operational hours and learning the process and finding any challenges that comes in. Now I talked about the dynamic operations, and as you can see that this is one of our unit that we're seeing one of the week how the system was running. As you can see that we had an electrolyzer output of 1. That means 100% system was running, and then all of a sudden we need to switch it off, and then we start again. So that means that 1 unit, when you run it a day, it basically going through 2 to 3 times of power off, power on, or operating in the lower load capacities. And that's what Stiesdal units are doing it. And that's what one of the main challenges with alkaline electrolyzers, that they cannot work dynamically that nice. And that's what we see that they are working actually. So if we look at industrialization and dynamic operations, we see that they are basically key factor in reducing the prices of any technology that we would like to implement. If you see over here, we see a 100 megawatt plant capex. How would that look like in Stiesdal 2025? Somewhat sitting at 1,000 euro per kilowatt. That dropping down to 400 something euro per kilowatt in 2030. If we calculate the hydrogen cost by assuming these factors, where we grid electricity is 50 euro per megawatt, and if we have a PV, then it's a 15 euro per megawatt. And with all the other factors here, what we can see that hydrogen cost, and it's a projection from 25 to 2030. And if you see that one with the 2 system where Stiesdal electrolyzer is on a grid, or with the solar PV powered, then we would see that the cost of projection of the solar power goes lower in 2030. But overall, the cost currently are somewhat within the case of fossil fuel if we add the CO2 cost adder. And if we do not have CO2 cost adder, then yes, fossil hydrogen is better, but we probably come in the range in 2030. And that's all I have for today. Thank you.
Thank you so much, Harish. Do you have any question? I don't see any chat. If any specific questions that has popped up. And thank you very much for actually finishing quicker than the 15 minutes allocated. So we actually have a few minutes again now. I would request next Christos to share his screen and then enlighten us with the research that he does.